Guys, so now we're on to, this is Unit 2, review number 2. It's our second review. So we've muddled through the first review, and now this is where you should start building back your confidence, because now you've seen each of the problems from the first review, so you know what to expect now, and so you should get that same feel here. So number 1, it says to show the calculation that verifies that the function f of x equals 2 over 3x is its own inverse. And remember the first review. It has a similar question to that. Milo made a mistake. He didn't go forwards and backwards. He didn't show f of g of x equals x and g of f of x equals x. But this time we don't have a g of x. We have f of x and f of x because we need to show that f of x is its own inverse. So let's write it twice, because we need to plug it into itself to show that it's going to equal x. Okay, so I'm finding f of x. So I need to take one of the f of x's and substitute it in for the x and the other f of x. So let me zoom in a little bit more. So I'm going to get f of x equals 2 over 3 times, but now I'm plugging in 2 over 3x in parentheses there. Okay, and what's going to happen to those 3's is that one's in the numerator, one's in the denominator. They're going to cross cancel. So now I really just have 2 over 2 over x. Well, let's take that first fraction bar there and let's change it to the divide symbol. So this is really 2 divided by 2 over x. And dividing fractions is easy as pie. You flip the second and multiply. So this is 2 times x over 2. And then these 2's cross cancel, and then all that's left is an x, which is what we needed to show, that f of x is its own inverse. You can't go forwards and backwards with this one because f of x and f of x are the same function. So that's it. So that is the work that you have to show to answer that question. All right, number 2, it says determine the domain and the range of f of x so that both f of x and its inverse are functions. You have exactly a very similar question on the first review. So remember, this is an x squared, so it's a parabola, and it has been shifted. To the right 1 and up 3. So if I draw a little sketchy sketch, right 1 and up 3, the vertex is up here. It's a parabola. It's an upward facing parabola because the x squared is positive. And remember, parabolas are not one-to-one. We have to restrict the domain. We have to take away half of the function. Now, which half that we take away is determined by what they give us here. So I kind of skipped ahead. But they only gave us f inverse of x is equal to a positive square root of x minus 3 plus 1. So that means we're dealing with the top half of the sideways parabola, which means I need the positive half, the right half of the upward facing parabola. So everything has to do with that x value there. And they want us to find the domain and the range this time. So these x values start at 1. And because we're cutting off the left, that means they can't go lower than 1. It's 1 to infinity. So x's have to be greater than or equal to 1. So x is greater than or equal to a 1. And that's it for that one.
6, 7.
Oh my gosh. For the range, that has to do with the y value. The y value being used here is a 3, and it never goes below 3. So it's 3 to infinity. So that means these y values, or f of x values, have to be greater than or equal to a 3. And this was a fill-in-the-blank type of situation. So I'm going to highlight that whole thing. Now, if you're not sure about the inequalities to use, then go ahead and just write the domain and range separately in interval notation, but we should be able to understand both. You see inequality notation a lot too, so we do need to be able to recognize that as well. All right, number 3, the graph of the function f of x is shown in the xy plane. It is a line, okay? It says which of the statements describe the function f of x and its inverse f inverse of x? Well, just like the one on the first review, let's find some exact points here and Freaky Friday them. So if I Freaky Friday -4, 0, I'm going to get 0, -4. Now, I know I don't have all the way down to -4 down here, so I'm just going to pretend that that's 0, -4, okay? That didn't give me enough room. If I Freaky Friday 0, 2, I'm going to get 2, 0. If I Freaky Friday 4, 4, I'm going to get 4, 4. So here's F inverse. Okay, so two lines are going to crisscross, and of course they're reflected over the line y equals x, because that's why we Freaky Friday. And here we go. Now we got to figure out, well, which statements describe the function of the inverse. Well, f of x and its inverse. So it says the x-intercept of f inverse is negative 4, 0. F of x goes through negative 4, but f inverse goes through an x of 2. So A is not it. The y-intercept of f inverse is 0, negative 4. Yeah, the inverse is going through the y at negative 4. That is true. The graph of f inverse intersects the graph of f of x at 4, 4. Yes, they crisscross at 4, 4. That is true. The domain of f of x must be restricted. Hold the phone. This is a line. Lines don't need to be restricted, so that is not true. The graph of f inverse is a reflection of the graph of f of x across the line y equals x. Yes, all inverses reflect across that line. That is definitional. The slope of the graph of f inverse is the negative reciprocal of the slope of the graph of f of x. Well, what does that even mean? Well, you've learned this before in Math 1. A negative reciprocal, we also call it an opposite reciprocal, means that these two lines are perpendicular. And they're perpendicular if they cross at a right angle. And these two lines do not cross at a 90-degree angle. So that is wrong. So the only viable options are B, C, and E. You will see a lot of select all that apply, and juniors or future juniors in the room, that's a lot of the types of questions you see on the state test also. They always give you select all that apply. All right, number 4, it takes t equals 1/2 the square root of h minus 5 seconds for an object dropped from a height of h feet above the ground to land on a 5-foot tall platform. What are the reasonable domain and range of this situation? All right, so this was not multiple choice, so you get to write the domain and range however you want. So whatever notation. But I'm just going to rewrite this function because I don't have room to write around it. And it's a square root function because, hello, there's a square root. The 1/2 out front means a vertical shrink because it's less than 1. But what's going to change the domain and range, because this does not change the domain and range, this transformation does, because it shifts our parent function to the right 5. So if I were to draw a quick little sketch, 1, 2, 3, 4, 5, that means that from the origin has been shifted to the right 5. It's the top half of a sideways parabola because there's no minus or plus and minus in front of that radical. So there it is. So now let's write the domain and the range. Well, the x that's being used is going from 5 to infinity. The y value there is 0, and we're never below 0. We're only above 0. So it's going from 0 to infinity. Bada bing, bada boom. All right, next one. Number 5 says, what's the solution to the equation? And we've got to solve it. Now, this one is tricky. So I need you guys to lock in right here. See this 5 and this minus 3? That 5 is not attached to a radical. But this negative 3 is attached to a radical. You cannot combine like terms. Say it with me. I cannot combine like terms because they are not like terms. One's attached to a radical, one is not. So what we need to do is we need to isolate this radical. And the first thing we need to get rid of is that 5. Now it's a positive 5, so the only way to move it to the other side is to subtract the 5. I'm going to finish my steps over here. So we're going to have negative 3 square root of x plus 1 equals 2 minus 5 is negative 3. Okay, now we can get rid of this negative 3. It is next to the radical. Next to means multiplication. You undo multiplication by division. So we're going to divide both sides by negative 3. And negative divided by negative is positive, and 3 divided by 3 is 1. So this is just the square root of x plus 1 equals 1. Now we can take the square root off, which means we have to square both sides, but 1 squared is just a 1. The x plus 1 goes poof, it comes out. All right, and then all we have to do is subtract 1. So we subtract 1 on both sides, x equals 0. But this is a radical equation, a square root equation. So just like your CFA, our third CFA that we took not that long ago, we have to check our solution before we claim that it is the true solution. So 5 minus 3 square root of, but instead of x, I'm going to plug in a 0. 0 plus 1. Is that going to equal 2? All right, well, here we go. By order of operations, we have to take care of the radical first. So 0 plus 1 is 1. The square root of 1 is 1, and negative 3 times 1 is a negative 3. Hey, 5 minus 3 does equal 2, so that checks out. So x equals 0 is, in fact, the solution. But you got to check it. So this type of work I would be expecting to see. If I don't see your check it work, I can't give you full credit on that problem. So it's just like the CFA. So you got to make sure that you do that. Okay. All right. Number 6. Elias's solution to the equation is shown below. What was the extraneous solution and when was it introduced? So they want to know what the extraneous solution is, and they want to know when it was introduced. Okay, so it doesn't say that Elias made a mistake. So that means we can assume that he did not make a mistake. So they stopped right here. They didn't finish it. So let's finish it. Let's find these two solutions. X equals negative 4 and x equals 1 when you solve each of those. And remember, this is a square root equation, so we have to check them by plugging them back into the OG, the original. So let's try the negative 4. Negative 4, is that going to equal the square root of negative 4 plus 8 minus 2? Let's see. Negative 4 plus 8 is 4. The square root of 4 is 2. 2 minus 2 is 0, though. Negative 4 does not equal 0. So there is our extraneous solution. So we know what it is. It's a negative 4. So we could stop. So we know then that it can't be A, because that says x equals 1 is the extraneous, and it can't be C, because that also says x equals 1 is the extraneous. So it means it's got to be B or it's got to be D. Well, now we got to figure out, well, which one tells us when it was introduced? Well, look at how many solutions we got here. We got 2. We got 2 solutions because we had 2 factors. We had 2 factors because we had an x squared, a quadratic. We had a quadratic because to get rid of that radical, we had to square both sides, and that's how we got the x squared. So, introduce when isolating the radical term? Nope. Introduce when squaring both sides of the equation? Yes. That is it. Letter D. Number 7 says, what is the inverse of the function f of x equals 36x to the 1/2 power? Well, you guys got to remember what 1/2 power means. Remember, that means it's a square root. So let's rewrite this. Instead of f of x, let's put y. So y equals, and instead of a 1/2 power, let's put the square root of 36x. Now, this whole thing is in the parentheses, so that whole thing is going to be under the radical because it's underneath that 1/2 power. All right, Freaky Friday, let's switch the x and the y because we're finding an inverse. And then we need to solve for y. So we need to release it from the radical, which means we have to square both sides because it's a square root. So we have x squared is equal to 36y. We need to get rid of the 36 in front of that y, so we need to divide both sides by 36. Now, what's the number in front of that x squared? It's a 1. So when I write my answer, f inverse of x equals, that's really just a 1/36 x squared. So it's got a massive vertical shrink on that sucker. And there is my inverse equation. Okay. Number 8, it says, what is the inverse? So another inverse one. Equation of the function g of x equals 1/4 x minus 2 cubed minus 1. And here's where we have 2 ways. So I'm going to do this again. You can use the easy peasy shortcut if you remember it properly, Or we can Freaky Friday like we just did in the last problem. Okay, so I'm going to start with actually, we can't use a shortcut. Never mind. We have to go straight to way 2. And that is because of this. Because of that vertical shrink that's out front, I can't do the shortcut. So good thing I noticed that. All right, here we go. So we have to do it the long way. So Freaky Friday, we have to change g of x to y. So y equals 1/4 x minus 2 quantity cubed minus 1. Okay, and then Freaky Friday, so x equals 1/4 times y minus 2 quantity cubed minus 1. And then we need to solve for y, so we need to start getting this stuff away from the y. So we're going to need to add 1 to both sides, reverse order of operations. So x plus 1 is equal to 1/4 times y minus 2 quantity cubed. We need to get rid of that 1/4 in front of the y minus 2 quantity cubed. And the only way to get rid of a fraction is to multiply by its reciprocal, because then the 4's will cross cancel. But that means I have to multiply the other side by 4/1. But 4/1 is just a 4. I don't really need the fraction part there because it's just a 1 anyway. So we do need to distribute that. I'm going to rewrite this line up here. So I'm going to have 4 times x is a 4x. 4 times 1 is a 4. So 4x plus 4 equals y minus 2 quantity cubed. Okay, and now I can finally get the cube to go away. So I'm going to have to take a cubed root on both sides. So I'm going to have the cubed root of 4x plus 4 is equal to poof, y minus 2. And then we need to get rid of that minus 2 by adding it to both sides. So then we could put y equals, but let's put the function notation back on. It says g of x, so g inverse of x equals the cubed root of 4x plus 4 with a plus 2 tacked on the end. And there is our inverse. So we cannot use a shortcut if there is a vertical stretch or shrink out front of the function. You have to do it the regular way. Number 9. So let me zoom out a little bit. It says, which of the following points lie on the graph of the inverse of this? So we're going to need to find the inverse of this function. This we can use the shortcut on because there is no vertical stretch or shrink. Cubed root of x plus 1 minus 2. So the rest of this problem is on the next page. Couldn't fit it all together. So f of x equals, this is the original function, cubed root of x plus 1 minus 2. Okay, so I need to find the inverse of this function, and let's go ahead and just use the shortcut, because I've shown you guys how to Freaky Friday this a couple times already, so I'm just going to go for it. Using the shortcut, the inverse opposite of a cubed root is something cubed, a cubic, and this shift right here, plus 1, that means it went to the left 1, which means I have to switch that for an equal type of move, but a vertical move. So left is a negative. So that means when I switch it for a vertical move, I have to switch it to down. So it's going to be down 1. And this minus 2 on the end means it's going down 2, which is also a negative move. So when I switch it for a horizontal move, the horizontal move needs to be negative, which means it would be an x plus 2, because that means it's got to go to the left, and we see to the left if there's a plus in with the x in the parentheses. All right, so now what we got to do is we got to test out which of these points are on the inverse. So let's do a good old-fashioned table of values. Okay, we got to test out a -1. We got to test out a -2, a 0, a 26, and then it says -2 and 0 again. We don't need to do it twice. It's only going to need the one time. Okay. All right, so let's plug them into our inverse. So -1 plus 2 is a 1. 1 to the third is 1. 1 minus 1 is 0. -1, 0. Nope, that's not at all what that says. All right, let's try the -2. Well, -2 plus 2 is 0. 0 cubed is 0. 0 minus 1 is -1. So it should be -2, -1. That says -2, -3, so that ain't it. But this one down here, letter F, says -2, -1. So that's one of them. If I plug in a 0, 0 plus 2 is 2. 2 to the third power, 2 times 2 times 2 is 8. 8 minus 1 is 7. So 0, 7. Oh, yep, that is C. Plug in a 26. So that means it also can't be E, because E is 0, -1, by the way. And now we need to test out the 26. 26 plus 2 is 28. 28 to the third power. 28 times 28 times 28. Let me see. It's going to be a big number. Yeah, 21,952. And then even if I subtract 1, it's going to be 21,951. That's not a 1. So that ain't going to work. So it was just C and F. Number 10 says, what are the restrictions on x for the rational function? So we just need the restrictions, which means we only need to focus on the denominator. So I don't care about what's going on top of this fraction. I do need to factor this so I can see the restrictions. So two numbers that multiply to -3 and add up to -2. Let's see, it's got to be a -3 and a +1. So x is going to equal 3 and x is going to equal -1. That's it. So those are my two restrictions. So x can't equal these things, so make sure you state can't equal them. And that's it for number 10. That was easy. So a lot of these, even though it seems like there's a lot of problems, because there will be a lot of problems on your test too, but a lot of them are super quick and easy, as long as you remember your definitions. Which if you're practicing these, if you're doing these reviews and watching these videos, you're practicing, you will remember. If you are not, however, you're not even hearing me say this, so you're not going to do well if you're not watching these. All right, so it says, which of the following is equivalent to this quotient, means division, of rational functions? So we need to simplify all the way. Notice that the answer options do not have any restrictions, so we don't need to worry about listing those. We just need to simplify the dang thing. Which means, first of all, we need to factor everything. So we have two fractions being divided. The first numerator, x squared minus 1, that's a difference of two perfect squares, x plus 1, x minus 1. And the denominator, we have an easy trinomial, two numbers that multiply to 6 and add up to -5. That's going to be x minus 3, x minus 2. Two numbers that multiply to 3 and add up to -4. It's got to be -3 minus 1. Two numbers that multiply to -2 and add up to -1. It's got to be x minus 2, x plus 1. All right. And so, again, we don't need to state restrictions, so we can go straight for flip the second and multiply. So we have to rewrite this. X plus 1, x minus 1, x minus 3, x minus 2 times x minus 2, x plus 1, all over x minus 3, x minus 1. Flip the second and multiply. Now we can get cancel happy. Let's see. X minus 1's cancel. X minus 2's cancel. And that's it. So all I have left is x plus 1 times x plus 1. So that's an x plus 1 squared in the top. And I have an x minus 3 times an x minus 3. So I have x minus 3 squared in the bottom. X plus 1 over x minus 3. So, oh, that's just A. Bada bing, bada boom. There it is. Number 12 says to simplify. So we got to subtract fractions. So we're going to need to get a common denominator. So I'm going to write this a lot bigger because it's just too small for my old eyes. And while we're at it, let's go ahead and factor that denominator. X squared minus 4 is a difference of two perfect squares. X plus 2, x minus 2. All right, so now we can see what is missing. So the other denominator has everything. This one has one of the factors that needs the other one. So it's missing an x plus 2. So we need to multiply that top and bottom. Okay, so now we've got the common denominator. We can write it as a single fraction because we're going to subtract them. And we'll have an x plus 2 and x minus 2 in that denominator. And then we need to distribute that x. X times x is x squared. 2 times x is a 2x. And then minus an 8. Okay, well, we need to see if that numerator is factorable, because if it is, then something might cancel. So let's factor that numerator, or try to at least. Let's see, two numbers that multiply to -8 and add up to 2. Well, I know it's got to be a 4 and a 2, but it's got to multiply to a -8, so one of these is negative. It's got to add up to a +2, so the 4 needs to be positive. Oh, and something is going to cancel. The x minus 2's. Now, it doesn't say to state the restrictions, so we're not going to worry about it. We're just going to put x plus 4 over x plus 2. Bada bing, bada boom. If you were to state the restrictions, though, x can't equal plus or minus 2. Number 13, Lindsay says, the following rational expression simplifies to 1. Write a statement that gives the best evidence of this for all values of x. So we need to basically show that it's going to simplify to 1. So, well, let's see. That's really small. So I'm going to write this a lot bigger. So we've got 3 over x minus 3 plus x over x plus 3. That's our numerator, so I'm just going to focus on that for right now. We need to get a common denominator in order to add these. So let's see, this one needs an x plus 3, so I'm going to need to multiply that top and bottom. This one needs an x minus 3. Got to get that common denominator, that LCD. Okay, so now our common denominator is x plus 3, x minus 3, so we can write our common denominator. In the numerator, we have to remember to distribute. So 3 times x is 3x, 3 times 3 is 9, so 3x plus 9. Distribute this x, and we're just adding, so we don't have to worry about a negative there. X times x is an x squared. X times -3 is a -3x. Ooh, something's going to happen to those 3 x's. One's positive, one's negative. They turn into a 0. So all I have left is x squared plus 9 all over x plus 3, x minus 3. All right, so remember, that's just the numerator. That's just the numerator. We haven't even touched the denominator yet. Okay, so now, maybe let's put out front num to abbreviate for numerator. And now let's look at the denom for denominator. Okay, so in the denominator, I'm just going to write it. We've got x over x minus 3 minus 3 over x plus 3. Okay, we need to get a common denominator, so this one needs an x plus 3. It's got to multiply it top and bottom. This one needs an x minus 3, so I'm going to multiply it top and bottom. All right, and so then I'm going to get, well, the common denominator is an x plus 3 and an x minus 3. Ooh, just like the numerator. And we're going to have to distribute this x. X times x is x squared. X times 3 is a 3x, so x squared plus 3x. Now this one's minus, so it's not just a 3, it's a -3 that we have to distribute. We have to be careful when we're subtracting. So -3 times x is a -3x. -3 times -3 is a +9. And then, oh my gosh, the same thing just happened. The x's cancel, so they add up to 0. And all we have left is x squared plus 9 over x plus 3x minus 3. So remember, I'm going to put that middle fraction bar back. I have the same fraction in the numerator as I do in the denominator. So we can say the numerator and denominator are the same. So it does equal 1. But you have to show it. So you have to do the work to show it. Okay. Number 14 says, Andrew makes and sells acoustic guitars. Materials cost $25 per guitar. There is a $100 rental fee for the machine he needs to make them. Function g of x equals 25x plus 100 over x represents his average cost per guitar. Average cost again, if he plans to make and sell x guitars. Plot the points on the graph to show Andrew's average cost to make X equals 1, 2, 3, and 4 guitars. So the one in the first review was a multiple choice one, but we still had to graph it. Now this one's not multiple choice, but we still have to graph it. And they gave us X values to plug in. Just have to plug and then plot. When we plug in a 1 for X, 25 times 1 is 25. 25 plus 100 is 125. 125 divided by 1 is 125. So when X is 1, Y is 125. Plug in a 2. 25 times 2 is 50. 50 plus 100 is 150. 150 divided by 2 is 75. So 2, 75. Plug in a 3. 25 times 3 is 75. 75 plus 100 is 175. 175 divided by 3, I don't think that goes in evenly. It is 58.333333. So 3 with the bar. So 358.3 is approximately right here. And if I plug in a 4, 25 times 4 is 100. 100 plus 100 is 200. 200 divided by 4 is 50. So 450. And there's our graph. Bada bing, bada boom. All right, number 15, it says the graph of a rational function is shown below in the xy plane. What are the equations of the vertical and horizontal asymptotes? Okay, so here's where it gets a little bit tricky to see where the VA and the HAs are. So I like to look at where we're hugging walls. So I'm looking at this one. It looks like it's hugging x equals 1, but this one looks like it's hugging x equals 2. So if you picked either one of these, now the graph on the test is going to be similar question. The graph on the test is going to be very clear. It's just going to be one option, okay? So it's a 1 or a 2, okay? So we'll come back to the VA. It's got to be 1 or 2, okay? So x equals 1 or x equals 2, which it has them both listed here. So let's look for the HA. So the HA is where we're looking at the horizontal line that it's hugging. And it looks like they're both approaching a y value of 2. So that one we know for sure. It's y equals 2. So y equals 2 is only shown in B and C, so it can't be A or D. Okay? And so honestly, because this graph is just so terrible, believe me, the one on the test is way better. There will only be one viable answer for the vertical asymptote. I think though, because this one's hugging this wall more closely, it probably can't cross this wall. So I'm going to say x equals 2 would be the best answer there. Okay? Because eventually this one's going to get closer and closer and closer and closer to it. So I would say at x equals 2, which means that the answer is B. But like I said, guys, don't stress if you're worried about that happening on the test. It's very clear what the VA and the HA are. It's not going to be it could be this or it could be this. It's not going to be like that. If it is, then that means that you're not understanding what you're seeing. All right, number 16, it says, what is the horizontal asymptote of the graph of f of x? So it's just asking for the HA. So we got to ask ourselves, big top, big bottom, or same. And we have the same degree, top and bottom. So when it's the same degree, the HA is at y equals, we need the LC in the top over the LC in the bottom. The leading coefficient top and bottom is just a 1. 1 over 1 is 1. So there is our HA. Bada bing, bada boom. Okay. And then number 17, company spent $400 to make 5 robots. Producing more robots will cost $20 each. The average cost to make and sell a total of X robots is R of X equals all of that. Enter the numbers in the blanks to complete the sentence about the graph of R of X. The graph of R of X has a horizontal asymptote at, so big top, big bottom, or same. In order to see big top, big bottom, or same, we're going to need to simplify this. So I'll put it down here. So R of X equals, need to distribute that 20. So that's 400 plus 20x minus 20 times 5 is 100 all over x minus 5. Combine like terms, and let's put it in standard form. So 20x plus 300 all over x minus 5. All right, big top, big bottom, or same. We've got the same degree, top and bottom. So that means the HA, the horizontal asymptote, is the leading coefficient of the top over the leading coefficient of the bottom. So y equals the LC in the top is a 20. The LC in the bottom is a 1. 20 divided by 1 is 20. So the HA is at y equals 20. So the average cost to produce each robot approaches but never reaches 20 bucks. And there it is. Number 18, Ashley says the graph of the function f of x has a hole at x equals -1 because -1 is a 0 in the numerator. Why is she incorrect? All right, she made a mistake. Now, I see what she did here. If you solve x plus 1 equals 0, you are going to get x equals -1. But holes only occur when they cancel out, when factors cancel out in the numerator and the denominator. So we can say, well, let's factor it. So let's see, we're going to have x plus 1 in the top. And we're going to have, let's see, two numbers that multiply to -2 and add up to 1. So plus 2 minus 1. Nothing's going to cancel. So she is incorrect. So we can say Ashley is incorrect because there isn't a common factor of, well, that would be when you add it to the other side, that would be x plus 1. There isn't a common factor of x plus 1 in the numerator and denominator. We have to have a common factor top and bottom in order for a whole to cancel out. That's what makes a whole. Okay, so that statement right here, this is the answer. So sometimes our answers are write-ups. Sometimes it's an FRQ. All right, number 19, suppose y varies inversely. Ooh, this wasn't that long ago. Y varies inversely as x. Okay, so remember that is the form y equals k over x. We learned that not that long ago. That was in 12.1. It says when x equals 4, y equals 10. All right, so we need to try this first. We need to plug in a 10 for the y. We don't know k. We need to plug in a 4 for the x, and we're going to solve for k. We need to use the first set of information to find out what k is. So to get rid of that 4 in the denominator, we need to multiply both sides by 4. So that means that k is equal to 40. 40 times 10, or 4 times 10 is 40. That's not the answer though. Now here's the question. What is the value of y when x equals 2? This is the question. So now, same problem, y equals k over x. And we're trying to find what y is, but now we know that k is 40, and they're giving us that x is a 2. Well, 40 divided by 2 is 20. Bada bing, bada boom. Number 20 says the function h of x is a transformation of the parent function. Which of the following describes the function h of x and its parent function? Select all that apply. Okay, here we go. Well, if we look at this function right here, we can already tell that anytime we see x plus a number together, that means that's to the left, so it's going left 1. And this minus 3 on the end means down 1, or sorry, down 3. So it's going left 1 and down 3. So we know those shiftings of the parent function. But then when you look at the answer options, it says x-intercept of this, y-intercept of this, vertical asymptote at x equals -1, horizontal asymptote at y equals 1, translated up 3 units, translated left 1 unit. All right, well, we already know this one. It did not go up 3, it went down 3. So it's not that. It did go to the left one, though, so we know it's F, but this is a select all that apply, so that's not the only answer. Okay, well, we know that if we were to graph this, the parent function gets shifted left 1, down 3. Well, moving it to the left moves the vertical asymptote to the left. And our vertical asymptote is the restriction of the denominator there. So x can equal -1. So h of x has a VA at x equals -1, that is true. h of x has a horizontal asymptote at y equals 1. Well, this has been shifted down 3 units, so it's actually y equals -3, not y equals 1. It should be y equals -3 because it was shifted down 3. So D ain't it. Now we need to check x and y intercepts. So remember, to find an x-intercept, you have to set y equal to 0. So y is the h of x, so 0 equals 1 over x plus 1 minus 3. We got to solve for x, so we got to add that 3 over. 0 plus 3 is a 3. I'm running out of space, that's why I'm not writing it. Got to multiply both sides by x plus 1 to get rid of that x plus 1 in the denominator. I don't know why I have 2 parentheses there, but whatever. So 3 times x and 3 times a 1, so that would be 3x plus 3 is equal to 1. Subtract that 3 over. 1 minus 3 is a -2. Divide both sides by 3. X is equal to -2/3. Is that what it says? Yes. So A is one of them. Now let's find the y-intercept, and that's where we set x equal to 0. So plug in a 0 for all the x's. Well, if we have a 0 there, then that's just a 1 over 1 minus 3. 1 minus 3 is -2. So the y-intercept is -2. Oh, nope, it says it's a 3. That's wrong. So A, C, and F are the correct answers to the select all that apply problem. All right, and then number 21. Is that the last one? Oh, it has 22. 2 more. So it says, what is the extraneous solution to the rational equation? OMG, it wants an extraneous solution, the one that we get that doesn't work. So remember, that's going to come from the restrictions, and we know x squared minus 1 factors down to x plus 1, x minus 1, and we have x plus 1, x minus 1 on those other 2 fractions. So we know that the 2 restrictions are plus or minus a 1. Okay, +1 and -1. Can't equal those. So one of the extraneous solution is one of those numbers, pretty much. So let's figure out which one it is. So x minus 3 over x minus 1 minus 2 over x plus 1 equals x minus 5 over x plus 1, x minus 1. Okay, so remember, when we are solving a rational equation, we got to eliminate the denominators. So basically, I need to get rid of an x minus 1, so I need to multiply everything by x minus 1. But I also need to get rid of this x plus 1, so I need to multiply everything by x plus 1. Oops. And now I can get cancel happy. So these x minus 1s will cancel. So I'm going to have to multiply and distribute x plus 3 times x plus 1. So let's see, x times x is x squared. X times 1 is an x. -3 times x is a -3x. And -3 times 1 is a -3. Okay, so that's just that first term. Here, the x plus 1s cancel. And that's not just a 2, that's a -2 that we have to distribute. So that would be a -2x, and then negative times negative is positive, so +2. These all cancel, so then all we have left on the right of that equals is x minus 5. All right, we need to clean this up. We're going to need to combine like terms, and then because of that x squared, we're going to need to get everything over on this side and equal 0 on the other. So let's see, x squared is the only x squared. X minus 3x is a -2x. -2x minus 2x is a -4x. -3 plus 2 is a -1 equals x, oops, that's a minus 5. We need to move that x by subtracting it, and we need to move that 5 by adding it. So I'm going to bring this up here. So we're going to have x squared minus 5x, -1 plus 5 is a +4 equals 0. Let's product sum it to factor it to solve. 2 numbers that multiply to 4 that add up to -5. It's got to be -1, -4. And we're going to get x equals 1 and x equals 4. So this one is the actual solution because the restriction is that x cannot equal a positive or a -1. So x equals 1, that is our extraneous solution, but that is the solution that it wanted. That is the droid it's looking for. So this is the correct answer. Okay. Last but not least, says the function f of x is graphed on the xy plane below. What is the solution to the inequality where it is less than 0? So less than 0 means we are below the x-axis. This is where we would grab a highlighter and highlight the spot of the graph where it is below the x-axis, and this is the only sliver that has it. Now, there are no asymptotes drawn in on this graph, so we have to think about this. So you can see that these are hugging walls, and it looks like it's hugging this vertical wall here at x equals 2, and it looks like it's hugging this horizontal wall right here at y equals 3. The reason why I need that is I need this interval of x values, because that's the solution. Remember, we can't equal, so x is going to be in between, and we have to use the less than symbols only, no or equal to, because we can't equal either side. And I need to know this x-intercept. I know that the wall right here is a vertical asymptote. It's at a positive 2. I need to figure out, well, what is that x-intercept? So this one I actually have to do a little bit of work. To find the x-intercept, that's where we set the y equal to 0. Sorry, there's a gnat flying in my face. All right, so that's basically where we set the equation equal to 0. So 0 equals 2 over x minus 2 plus 3. We need to solve for x. So I'm going to need to subtract 3 on both sides. Negative 3 equals 2 over x minus 2. I'm going to need to multiply both sides by x minus 2 to get rid of it in the denominator. And then we're going to need to distribute that negative 3 because we're not subtracting, we're multiplying. So that is negative 3x plus 6 is equal to 2. We need to subtract 6 from both sides. Negative 3x is equal to negative 4. Divide both sides by negative 3, and negative divided by negative is positive. And let's see, 3 goes into 4 one time with 1 left over. So 1 1/3 is the x-intercept. So 1 1/3. And there's my solution. That's it, you guys. Study, study, study.